Hey everybody, this is Rydo and we're back to another recording of Human Resource Machine. Let's hop to it. Last episode was the real turning point with multiplication workshop. Let's do zero terminated sum. Now, we may very well spend the entire episode doing every single puzzle, just one episode per puzzle. Yes, we believe in educating our employees on the job here. That's definitely true for this game. Do you know what a zero terminated string is? Yes, it's a very old technique and we don't expect you to know. So you may ask me about it if you like. Or you may ask an external source. Whatever helps you get the job done. So again, the game is just telling you, go Google it. Zero terminated strings. Were they really a thing? Maybe, but I don't really recall it ever using that because as far as the very basic code of characters and strings, we always had an end of line as far as my experience. A special character that doesn't show a font or anything called end of line, or carriage return, or there's a null string that is technically zero, but you wouldn't, not the zero you see, a different zero. Um, what is a zero terminated string? Yes, I can tell you. A string is just a list of values like 1, 2, 3, 4, 5, or 4, 99, 2. But how do we know when one string ends and then a string begins? We can mark the end with a special something, with something special, like a zero. Here are two zero terminated strings. 1, 2, 3, 4, 1, 2, 3, 0, 99, 8, 0. So those are two strings. See how that works? And sometimes the strings can be empty. Here are three strings. Notice that the middle one is empty. 1, 2, 3, 0, empty 1, 0, 5, 0. Yes, sadly, this means a string cannot contain the number 0. Since 0 means something special. Well, now we know. Back to work. And that would be the real reason why I don't think anybody has ever used a zero terminated string in their life. It's just ridiculous. So this box is filled with zero terminated strings. You add together all the numbers in each string. When you reach the end of a string marked by a zero, put the sum in the outbox. That's not too hard. So inbox, jump if zero to outbox, otherwise add to this. Which, let's see, so we need the inbox, copy to this, I think, then add to this, and then copy to this, and then outbox, and then jump back around. What's our optimization challenge? 10? We've got 7 here. So there's 3 more codes we need to do, and that would be this. Copy this from here, copy this to there. And that's 9. And I think that's all we need to do. So we should get 4 and output it. Nope. Let's see, add it to this, and then don't outbox. No, that's wrong. Outbox. Go this way and don't outbox until we're done. Let's try it now. This should be 12. 4 gets put here, gets added and put there. That's not what we need to do. That's not what we need to do at all. Let's try this again. Don't copy the 2 here. Instead do this at the beginning so we have 0. and that should work. We take the 0, we put it here, we grab this, we add it to the 0, that's good, and then we go back to this, which one shouldn't have done. That's wrong. Try that again. Put the 0 here, add this to this, put it down. Take this, add this to this, put it down. Take this, it's hit 0. And we forgot to copy from our running total. So we'll go ahead and label that running total. Why I'm bothering to label it right now, I don't know, since I'm done with the program. It's strange, that last puzzle was quite difficult, and now we're hitting this kinda easy one. Sort of good video game design there. You certainly want peaks and valleys in your action of your game. It would become irritating if after the most difficult puzzle, there's just a more difficult puzzle, all the way to the end. That's not going to encourage players to keep on trying. But it's a pretty drastic drop here between what we had and what we didn't. I just put 2 zeros out in these strings because of some reason, and yet the outbox accepted those. That's strange. They must have been positive and negative numbers that equaled 0. It hasn't given me an error, so I assume that was right. Well, I wasn't really paying attention. Notice it does 2 more steps at the end. So that took 10, but it took 92 steps. So instead of messing up this, let's go ahead and mark this as 1, copy it, and go to the next tab and paste it. And then we'll simply change this to 2, and let's see what we can do to remove the loops. I think all we really need to do is double up here. Again, we are in this odd situation where the real solution to make it faster is just to simply put the exact same code in it twice, and that's all we really need to do. So copy from this and outbox, and we're done. And so that should just eliminate this 1 jump for every loop. Let's see how many steps that takes. And it's not the number of steps it takes in this specific run, it's the average number of steps in all the possible inputs the game has hidden in its background. So it probably has 4 solutions, I would say, to everything. So that didn't help either. So next thing we would do is just triple it. Same code. There's really nothing else I can see to optimize, and we could do this almost the full number of inputs times. If we put more code after that, it wouldn't make it any faster if there's a specific run here. This isn't really in the grand scheme of things, saving a ton of time. Though it's still very much just kind of ridiculous. So hit play again, we'll run it again, see what happens. There's a little snow going on in the background. What's weird is if you step back or step forward, the background will jump back too. Over almost 3 times as long. And we've got it down to 88 this time. So it's same thing. It's the same thing. There's possibly different ways to make this faster, but when you have a program this simple, the argument that you should investigate it or that it possibly exists is really low. This is such a simplistic thing. How could you possibly make it faster? I can't see a way. It really feels like the right solution is this. Now, jump if negative as a code would not work on zero terminated strings at all. 88. Did I lower it any this time? Or have I hit something where it stopped saving me any steps? It shouldn't. This code particularly shouldn't have stopped saving me steps. But I might simply just be reducing it by a infinitely small number, 1 or 2 steps. That box. So it was 88 last time. How many will it be this time? We're up to 46 lines of code. 88 steps on average. It's not going down. And what was the number here? Hmm. 92. And there's no way to add an inbox or add something to the inbox. You can't. If you could add to the inbox until it was 0 and do it backwards, that would save you some time. So, what am I crossing as far as the barrier that rather confused how I could reduce the number of steps. This goes here. It seems like there's so much code that you would simply could not change. It kind of sucks. Most games, if I had spent a week playing them, I would have been able to show you the solution easily. But in this case, it's not happening. It's simply not happening. So it was 88 steps for this. It feels like it's gonna be 88 steps for this. We're at 55 commands, 87 steps. But there's still 10 steps missing. We finally added enough inputs we saw there to cover all of them. I don't think adding another set changes that. Is there some other way to do this? That's the real question. What would be the other way to do this problem and solve it? This should still be 87 steps, I would guess. Unless there is some input test where he gets all the way to the bottom of the loop. See, we're stopping at 48. We're not even going any further. And see, that just goes back to 87, which is far from 72. So what is the one thing that this potentially can, let's see. Inbox, jump of 0. Oh, we could do something like this. Instead of inbox jump of 0, then we could make a second command here where this instead jumps to this. No, because it still needs to test for 0 each time. That wouldn't help. Copy from retail, running total. Let's see, copy from 5 to running total. What jump of 0 goes to this. Outboxes goes here. This inbox. Jump of 0. Add to running total. What if we didn't copy the running total? Does that work? It shouldn't. take the 4, adds it. Then it just tosses it, yeah. Perhaps the trick here, before we change this, we'll move it over to 3. Perhaps the trick here is the inboxes and run if 0. So instead of changing everything, let's see, inbox jump of 0 to this point. Otherwise add it to this and copy to this. And otherwise jump up here. And then if this is 0, jump down here. So instead of duplicating this piece and duplicating this piece, I just duplicated the middle section. Let's see how that works. How many steps did that save me? If it's less than 92, I think we've solved it. But it's not less than 92. What if we inbox copy to running total, then added that, then copied to. So this, then this, and move that around and see if that changes anything. Will this still be 90? Nope, that's just wrong. So that doesn't solve the problem. This jump, I suppose, no, we can't assume that there isn't going to be an empty string ever. We could inbox 1 and then jump of 0 and then immediately jump to the outbox. If the first one ever is that, we could do that and then jump into this. That adds a special circumstance where we don't bother to try and add anymore, but it doesn't really change anything because this jump of 0 just, well, it skips 1 step. Maybe that's the 1 step we need. 0, 0s. So if this got us to below 92, at least we'd know we were in the right path. It added a step. It somehow added a step. Jump of 0 to outbox. What if it jumped at 0 to a special outbox then? jump of 0, just outbox it, go back to the beginning, and skip these 2 steps. Does this help making this one special circumstance? I don't think it is. It is helpful. I don't think it is a smart way to run a program or make a program. 89, okay. It solves this down to 89. So then we have to duplicate this inbox, copy from 5 to running total. Let's see, we'll put a little marker here. Inbox, jump from 0. If it's 0, outbox it, and then jump back to this point. Next inbox. Let's see, jump from 0 is what that's supposed to be. Next one, B. Copy to running total the first time, then inbox, then add to running total unless it's 0. Is that right? Yo, how that worked, I don't know. What? It has, the first thing we inbox has to be. No, it just jumps to the add. That's what it does if it's positive. So jump here to this add, then copy it to that. Otherwise, inbox again, and then jump if 0 to this point where we would copy from the running total again and outbox, and then jump all the way to the top of this. But if this one just jumps as is 0, jump here instead, and just immediately outbox, and then jump all the way to the top. Which probably means I don't need that one. This one should be going to this point, and let's see how many steps that is. Probably not enough. Expecting 9, but let's see. 6 plus -6 is 0 equals 0. There's a jump missing here. Here we go. I can't fully imagine how boring this must be. Honestly. This jumps of 0 to this point, which jumps to this point. Yeah, this jumps if 0 is supposed to be here. Honestly, it's fairly even that interesting as a fan and trained programmer. You certainly, if you're going to just program for your own fun, want to be motivated to achieve some goals here. This honestly feels very much like you're not achieving anything of any real note. You're just repeating things over and over again. So, in the effort of brevity, I think this would be the way we would solve this. Just copying it and going forward. But let's just go to my other file. I've already used my reference of my first file to do this, so why not do it again? I'm not ashamed to cheat. We just need to find the one that takes the least number of steps. I doubt it's number 3 here, but we'll run through number 3. With 11 commands, it seems unlikely that that's the solution. It'll be the solution for possibly... Really? So what's the deal about this one? We get the inbox, we jump if 0, otherwise we copy it to 0. Okay. So no copying this to this. Then we inbox, and then we jump if 0, and we add 0 to that, because it's already there, then we copy it to that. So it's a slight variation, like one thing is turned around in the order in how I had it. Let's see. So click here. 2 never worked, so we'll paste over that. Here's the solution. There is one jump at the bottom going to the top. There's one jump at the bottom going to the top. This and this is different. Instead it just does that. And then it has a jump of 0 and copy to 0. So actually there's a jump of 0 here. Where that goes, I don't know. Nobody knows yet. Let's see, where does that point it? To the very bottom, to outbox. So then copy to inbox jump of 0, add 0, copy to 0. Copy to inbox of 0, add that, copy to that. That was the same. Then there's this jump that goes back to inbox, whereas here this jump goes back to inbox just the same. And then copy from 0 is here, and so everything else is the same. Very, very close. And I certainly could have spent an hour doing that, or at least another 30 minutes doing it, but I don't see a point. This is definitely a new way for me to cover videos. I certainly almost always show my first impressions, what my first experience was. Here I'm showing you after several hours of that. So let's talk about the Fibonacci Visitor. One of the beginnings of the really, really difficult optional levels. This back hallway is for advanced employees only. Advanced is not emphasized enough. Are you sure you want to be here? These night shift assignments are optional, you know, and they are difficult. If you need to ask for help, I'll be just here looking through these catalogs for a golden spiral. Golden spiral is a reference to a Fibonacci sequence. For each thing in the inbox, send to the outbox the full Fibonacci sequence up to but not exceeding that value. For example, if the inbox is 10, you should send 1, 1, 2, 3, 5, 8. What's a Fibonacci sequence? Ask your boss or a friendly search box. Again, just go search it. So Fibonacci sequence starts with 1 usually. I guess you could have one that started with a different number, but then it adds to itself. So 1 plus 0 technically is not included is 1. 1 plus the previous number is 2. 2 plus the previous number is 3. 3 plus the previous number is 5. 5 plus the previous number is 8. 8 plus the previous number is 13, and so on and so on and so on. It's a special mathematical sequence that doesn't get used a lot, kind of in artistic and architecture things you might use it. What's the Fibonacci sequence? Each number in the sequence is the sum of the 2 numbers just before it. So what would you call a sequence that was the sum of the 3 numbers before it? Not a Fibonacci sequence, but something else. That's an interesting thing I should go Google. But I probably won't. The first 2 numbers are 1 and 1, so the third number is 2, 1 plus 1. Fourth number is 1 plus 2, that's 3. Fifth number is 2 plus 3, that's 5. Sixth number is 3 plus 5. And goes on for a while. Forever, really. Shall we continue? Let's leave that as an exercise for you. Back to work. So, example, if we have 6, we have to send out 1, 1, 2, 3, 4, 5, and nothing more because 6 is the max. And if we have 20, it would be 1, 1, 2, 3, 5, 8, and 13. And we're not going to probably get any inputs bigger than 20 because that would be too much. So, here's what we kind of know from the beginning. We're going to copy it to a slot that we're going to number. We're going to also, as setup, copy this to this and bump it up so we have 1. And then we could also copy that 1 to this. And I guess we could continue that route and do 1, 1, 2, 3, 5, 8, 13, and 21. Let's see, 8 and 13 would be 21. And so we could just fill it out like that. And let's go ahead and start that way. So 1 and 1, and then add 1 here, copy to this, and then add 1. So 1, 1, 2, add 1 here, and copy to this, and then add that, and copy to this, and then add, let's see, this, and copy this one, and then add this one, and copy to this one, and let's see if that's right. So we haven't done really any code here, we're just doing math. 1, put a 1 there. We didn't need to copy 2. 0 again. So 1, 1, 2, 3. 5 is being put in the wrong place. 8. Alright. So we need to change this. Change this. Change this. And we don't need to copy this to that. Double check. This is just hard coding the first few of the Fibonacci sequence. A very unrobust way of doing things, because who knows, at some point in the future your program may be asked to give the numbers up to 1,000,000. There's not enough space here for numbers up to 1,000,000. There's barely enough space here for 21. Let's see. So then we could just subtract 0. If negative, quit. Otherwise, outbox. Then we could copy from the number again, subtract this. If negative, quit, otherwise copy the next thing. Outbox, let's see. Then we need to subtract this one. This is a very bad way of doing things. It's not even an effort to make this robust. It's simply just getting it done. Let's see, copy from the if negative here, jump back to the inbox. If negative here, jump back to the inbox. Otherwise, copy from three and outbox. Copy from 2 and outbox. I'm filling in this as we go, doing it in a poor fashion, not going particularly in the right order, or thinking in a linear order. I'm more just jumping around all over the place as I increase the code length here. This is already far from our 19 or fewer commands, but it will probably get the speed challenge done, I would suspect, kind of easily. And maybe that's the right way to do each one of these puzzles. First try the speed challenge, then do the length challenge. That might be it. There is an achievement certainly for beating a program with 4 times as much code than the challenge limit. So if I go over 80 about, if this was 20, and so if I went over 80 things, then I'd get an achievement for that. I've already done that. Those achievements are easily done by simply adding a bunch of jumps like this, not like this, but like this, because each one of those would actually not change your code at all and just add it. And you can do that in the very first level easily. So we've got 2 more to do. Copy from this, subtract this. If it's negative, go back to the beginning. Otherwise, outbox, copy from 6 and outbox. One more time. Grab the number we were testing, and then we could do that. Now, since we don't actually need the 0 anymore after this code, we could have made one more space available by putting the input number 21 in this case right over number 9, and then we would have been able to have one more. Now, I don't think we need that because 21 is probably the biggest number that they're going to give us. They're making it rather simple on us for as difficult as this program is. This is a real program that you might actually need to program at some point if you wanted the Fibonacci sequence in something. And I'm not sure a math coprocessor would spit out the Fibonacci sequence. I'm not sure if Intel 8086 processing code spits out Fibonacci sequences out of a base address or pi for that example. It probably somehow has that written down, but maybe it doesn't. Or the prime numbers is another good example. Maybe it does try to calculate all of those, and certainly you could spin circuitry to have that to a certain extent programmed. Not pi per se or prime numbers because those are infinite, but if you had most of the prime numbers listed in a database, it might be helpful. There is one online that it's certainly easier to look up online than it is to see for yourself, for as high as the number of prime numbers we found are, millions and millions of decimal places. Last one, jump if negative goes here, and in theory there's no reason for this, so we can just leave this here. We should never reach this point. I think maybe there is a reason. So 1 1 2 3 5 8 13 and 21. That's our database now, pre-programmed. They want till 21. Subtract, it's a positive number, so send out the 1. Take 21 again, subtract it, still a positive number, take it out, send it. Take this, subtract, output that. I don't think I did that right. No, I didn't. So 21 would be 0, which tells it to send that out. And then we get into an infinite loop. Normally a computer would crash at this point. Or at least the program would lock up and you'd have to hit Control-Alt-Delete. Right, so this one, copy 1, then copy from the number, subtract 2, then copy from 2. That is right. Let's try that again. So 16 commands just to manually build this reference. This reference which only works up to 21. If they threw 22 at me, if they threw uh, any number above 21 even at me, the program would just crash and not work. So who would write a program like this? Uh, Short-sighted people. Short-sighted programmers who just want to get it done as fast as possible, who aren't, I guess, getting paid by the hour, instead of getting paid maybe by the finished project or the lines of code, which would be an awful way to be paid to pay a programmer. Uh, Now, yes, in theory, this is probably going to take the fewest number of steps that you could do this. Uh, it's just not robust. I could tell you from memory, you don't need a program to tell you the first 7 numbers of the Fibonacci sequence. You need a program to tell you like number 59 through 100. You need the huge numbers when it gets up exponentially bigger, because if you're at the 100th digit of the Fibonacci sequence, and let's just say for argument's sake that number is 1,000,000, and then the previous number was 500,000, well then you're 1.5 million that time. Next time you're at 3 million. Next time you'd be at 4.5 million. As far as the speed challenge, this is where you see incredibly faster. 156. Uh, so we beat that speed challenge quite well by using code in that way. So not always the wrong way to program, but there was no math in that. There was no logic. So instead, let's put it in number again, and let's see what we want to do. So copy from this, and then bump this, and copy to this first. That gets us 1. And then copy to this, that gets us 1, 1. Alright. So inbox copy to number. Add let's see, copy from, let's see, this. So we'll call this first. We'll call this second. And we'll call this one third. We're going to use less memory in this example, so we're not going to use these spots. So we're going to copy from third, subtract from the number, or copy from the number and subtract from third. So instead we'll just subtract from third. That works. If negative, what do we do? I think if negative we don't do anything, we just go back. But if positive, we outbox, we copy from third, and then we outbox that. Then we copy from first and add it to second, and and then we copy it to third, and then we ask, then we jump and we copy from third, from the number, and subtract from third again. So that's 14 lines of code. We're trying to do it at 19. Is that enough? Let's see, copy to third and then bump that one up. That's 16. 0 gets put here. You still kind of need to get the 1 going. Well, that was wrong. How about we do this instead? Subtract 1. First of all, copy this to number. Then subtract first. If it's negative, jump to the inbox. Otherwise, copy from first and outbox. Then what we do is we copy from first and add it to second and put it in third. I think we probably don't need third as something. How about instead we do copy from first, add it to second, and put it in third, and then copy from second and put that in first, and then we're too short, copy from third and put it to second, and then let's rename this temp and see if that works. So that probably means we could take out these 2 lines of code. 1, and then add that together and put the 2 there. See, we don't need that. By default have the 2 going. So let's speed this up. I think it's going to work fine. The only thing that could go wrong is if the subtraction here is wrong, and it does allow a number past 21. I think something did go wrong. I think what went wrong is a couple things. This needs to go back up to this point, and these 2 can go bye bye. That puts me at 19, right where we need to be. Let's hit play and speed it up. So it feels like I'm gonna be done with this puzzle and get both of the challenges in an incredibly short amount of time, in 1 hour, which is amazing to me because it took me probably 6 hours plus to do this before. Fibonacci sequence and the math behind it is not an easy concept to program for. Notice it didn't do both of the things. You can't be guaranteed that you will do both at the same time though. These challenges can be very difficult and in many cases not possible to optimize for both simultaneously with one solution. Uh, this game is kind of cheaping out here, saying it can be difficult, you don't have to play. Look here and just count the number of puzzles that you would be missing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 extra puzzles if you just took their advice and didn't do them, compared to the ones that you have to do. 1, 2, 3, skip this. 4, 5, 6, 7, 8, skip this. 9, 10, 11, 12, 13, skip that. 14, 15, 16, 17, skip that. 18, 19, 20, 21. So it feels like there's probably only close to 30 puzzles, 31 anyways, and if you didn't do any of the extra difficult ones, you would not even you'd be missing out on a third of them. That's not acceptable. That's not cool to say, oh, a third of this game, don't even bother playing it. It's a really kind of short game too, if you can figure out the things. There's not a ton of replay value or any other reason why you'd come back to it. Unlike their first game, World of Goo, that one seemed like it had some more replayability by a little bit, and definitely a lot more fun. It was much more architectural and interactive, and had more storyline. Anyways, that's gonna be it for this recording. As always, I ask you to like, share, subscribe, comment if you want to, and watch every second of my videos. All that helps out. If you want to support me, you can click on my name, Rydo. On the right will be a blue button that says support this channel. Click it, make a donation. And if you want to friend or follow me on basically any social media sites, there's a whole bunch of links down below. Thank you for watching. Have a good evening.